Welcome everyone to my first OChem video where I'm gonna be walking you through, or actually speedrunning through, this practice quiz. Okay? And it's related to Sn1 Sn2 E1 E2 stuff. Okay, so let's go. So first we have to rank these alkenes in decreasing stability. So how do you know when an alkene is stable? It's how substituted it is. The more substituted, the more stable it is. So let's stare at all the carbon atoms around this double bond. So for this one, we have 1, 2, 3. For this one, there's 1, 2. For this one, there's 1, 2, 3, 4. Whoa, so this one's 4, so it must be the most stable. And then this one has 3, so this one is the second most stable. And this one is the least stable. Okay. Next we have these. We have to predict the major organic products. And we don't need to show mechanisms. Yippee! So this one over here is elimination. This is polar protic. And this one is a small, strong base. Because we only care about base because it's an elimination reaction because it's hot. So for elimination, you have to find some hydrogen to attack, which creates an alkene and it makes the bromine leave. Okay, so maybe there's one here, there's also one here, and that's it. So what happens? What if this one goes down here and this one leaves? So I create a double bond over here, which now you have to compare the alkene stability again. 1, 2. Oh, this was only 2 substituted. What if we have this other hydrogen went down here? Now you have a tri-substituted alkene. So that one will be the hydrogen that gets stolen. Wait, like this. So the answer will be this thing right here. And the minor product. Whoops. So this is the major. And the minor product will be this other hydrogen, which is like that. But since this question is only asking for major organic products, you can ignore this. Okay. Next we have this one that looks like a pineapple. So since we have a salt thing over here, okay, you can just make this positive, and this one OCH3 minus. And this is dissolved, and it's the same thing as this, technically, so for me, I just ignore it. So this one's hot, so I'll favor the elimination reaction. Okay, so now what can happen? It's probably some E2 thing, because this is a strong base and it's small. But for these rings, cyclohexane rings, you actually have to draw the chair conformation to make sure that when this hydrogen here, or this hydrogen here, is anti-periplanar, because E2 reactions require the hydrogen to be anti-periplanar to the leaving group for some reason. No one knows why. So if you draw the chair conformation, okay, chlorine is pointing up. This terbutanol thing, terbutyl, is pointing down. I'll make it really tiny. And the other hydrogens are here, and this one's one here and down here. And look, in this image, you can see that this hydrogen is in fact not anti-periplanar to this chlorine. So this bond will never happen, even though it would form a more stable alkene. So this one is the hydrogen that will do stuff. So it'll send its electrons to here, making a double bond, and then go down here and making the chlorine leave. So it will look like this in the chair conformation. So the result will look like this. And this thing of course stays exactly the same because there's no reaction. Okay, next. Okay, second to last one, guys. Next we have this one. You can see it's 25 Celsius, so it's like room temperature, and DMSO is a polar aprotic solvent, which means it only solvates the positive charge stuff and leaves the negative charge stuff to do backside attack. So it is an Sn2 reaction. So this Sn2 reaction, you can see this thing is a secondary, so that doesn't help us at all because it could be anything. Because most of the problems you'll get is probably secondary because the OChem teachers are mean and want to make things hard. Okay, so let's get on with this mechanism. BR does a backside attack, taking the Cl off. And that's about it. And since it can only attack from the backside, the stereochemistry will be inversed. And so instead of a wedge, it will be a dotted line. Like that. Okay, that's the answer. Last one. And you can see, look at this. It's so big and fat that it can't get into the small gaps. Okay, looking at the 55 Celsius, it's elimination reaction. And also, since it's because there's a big base, it's also elimination. You can't really do substitution of a big R base. So you can imagine the K is gone and it's replaced with a negative charge. Like this. And now which hydrogen could it go to? So there's this hydrogen here, and this one would form the more stable alkene because there is 3 substituted things, but that won't happen because the base is too fat, so it can only attack this outside very exposed hydrogen like this. And so that's what occurs. So we goes here, this hydrogen bond goes down here, and then the bromine leaves. So as a result, you will get this double bond here. And I'm too lazy, so you can just draw pH, which stands for phenyl, if you want. And that concludes my speed run for this practice quiz. Okay, I'll see you guys next time, and hopefully I'll make some more videos. Bye!